Okay. Good evening to the Dr. KENNETH. So this is for the assignment of the digital signal processing that course BENT 4733. This assignment is about the digital filtering of the audio signal. So this assignment, we select the audio 20 to do this experiment. So my members team is PARWATHY, LIYANA, FATIN, AMIRAH, and me is WARIKYA. So this is our objective. For the first is to identify the unknown and unwanted noisy signals, to eliminate corrupted and unwanted signal using either FIR or IIR's digital filter that is need to determining filter order and coefficient in that. And FFT is about base filtering methodology. So for the third is to apply the knowledge obtained from the lecturer to accomplish the task by using the MATLAB software. So for the last one is to identify and analyze the excise, noise, and sinusoidal corrupted audio signal. So for the introduction is of this experiment or project need to the corrupted and unwanted signal that need to identify by the using either finite impulse response or the infinite impulse response digital filter. So and that after that FFT based on the filtering method. Then the two main classifications of the digital filter that used for the signal filtration are both of FIR and IIR. The measure of this difference is between both filter is a finite of the impulse response that is given by the first filter when the compared to the IIR. Here, the IIR is characteristic that filter that generate and the infinite duration impulse response for the dynamic system. So for the next slide, I pass to my partner, that is LIYANA.
Okay, in this part, I will explain about the result that we have obtained for the original audio unfiltered. Okay, next. Okay, this is coding for the original audio. We are using the FT function to see the frequency spectrum, and we using the spectrogram function to identify the signal in a visual way. And from the coding, we also using the sound function to hear our audio signal. So for the original audio, we hear that or we recognize that the sound is noisy and loud. Okay, next. Okay, this is for the simulation result. Next. Next view.
Next. Yes, next.
Okay, okay. For the spectrogram for for the frequency spectrum of the unfiltered audio signal, okay, we see that we generate by plotting using the FFT value. So this is our frequency spectrum that we obtain from the original audio signal. Okay, next. Okay, next view. Okay, this is the spectrogram for unfiltered signal. Okay, from the spectrogram signal, we can see that the noise signal is representing the signal strength or loudness of a signal over a time at 0 until 5 kHz frequency. So we can see that the brighter colors such as yellow color at the range between 2 and 3 kHz. That means it is correspondingly to the progressively stronger or louder amplitude. Okay, next I will pass to my friend.
Okay, to make the audio better, so we need to run filter. So here we choose IIR filter and three filter method to filter the original audio file. Okay, so this is the first filter. We use notch filter, and this is the coding for notch filter at 1 kHz. And the below coding is to generate the graph. Next. So for this simulation result, Okay, this is the pole zero plot. Next. Okay, next. This is phase and magnitude. Next. Next view. This is notch filter magnitude response. So the notch filter was applied at the first filter to filter out the high amplitude noise at high frequency. From the spectrogram, next result. From the spectrogram, there is some changes from the previous spectrogram with notch spectrogram. The noise was removed and the pole zero plot showed that the system is stable and the sound is played to observe the difference. But it's okay. At the end of the after we carry out all the three filter, then we can hear the clear audio. Okay, next. Okay, next we move to the second filter. So basically, this is the filter for band stop IIR filter, and as usual, the coding is to generate the result. Okay, next. Show all the result. So for the second filter, the band stop filter will apply as the second filter to filter out the noise at frequency between 1700 and 3300 frequencies. From the spectrogram, we show the result of the spectrogram. Okay, from the spectrogram and pole zero plot, the spectrogram shows the reducing of yellow color, which is we indicate the yellow color is a noise lah. The noise was removed and it is stable because the blue color, we can see that the blue color at the frequency 2 to 3 is more than the yellow color, and before that the original audio, the noise is at the 2 to 3 frequency. So the noise was removed and the system stable, then the sound was played again. Okay, next we move to the third filter. Okay, show all the coding and result. So this is basically the coding for the third filter. We use low pass IIR 2000 filter. Okay, next onto the result. So this is all the simulation result for the third filter. The magnitude and phase for low filter, and then the pole zero plot for low pass filter, and lastly the spectrogram and magnitude response of the band stop. Okay, so from the spectrogram of low pass filter, from this result, it clearly shows that the yellow color is reducing more in this part. Okay, the low pass filter was applied to the audio to lower the noise in the audio file in frequency more than 2000. Then the sound was checked again using the sound function. Okay, okay, next.
Okay, Parwathy boleh start.
Okay, for discussion,
Go.
for the original audio signal, which is unfiltered audio, the FFT function will apply to view the amplitude spectrum of the signal through the plotting process, and the spectrogram function is used to see in a visual way the signal strength and the noise loudness of a signal for a time frame of frequencies. So at first filter, the notch filter is applied to reject or block the transmission of frequencies within a specific frequency range and allow frequency outside the range to filter out the high amplitude noise at high frequency. The second filter for used bandstop IIR Butterworth filter at the range frequency between 1700 Hz until 3300 Hz frequencies. And the noise gets eliminated better using low pass IIR Butterworth filter. And in conclusion, the zero and pole graph is generated to check its stability, and the audio is tested again to check its stability and the sound smoothness after the filtering process. And we have applied IIR filter and used in digital filtering because we know that the IIR filter is required less filter order, thus less complexity. And that is all from us. Thank you.
Okay, thank you.